Alright class, this is going to be part 2 of the exam 1 review for Engineering Statics 2301. We're going to be doing problem 2.37. Again, I'm not going to actually display the problem itself, I'm just going to read it off and we'll get right on to it. So whenever point of time, feel free to pause the video and catch up when you are ready to go. Problem 2.37 states that knowing that alpha is equal to 40 degrees, determine the resultant of the three forces shown. I went ahead and drew the free body diagram of this force problem. I stated that G is going to be our global point. So point G right here is at that center. That's just global. You can label it whatever you want. Doesn't matter. I'm just stating where I'm looking at my point of interest. So we need to find our resultant. To start off, we're going to look at the 60-pound force. Double arrow. I'm going to break it down into X and Y components. We're going to have a positive 60-pound force acting at a angle of cosine 20 degrees, which this will come out to 56.382 pounds. And how I got that angle is simply just because of right here. From the horizontal, it states that this angle beta that I labeled is at 20 degrees from the horizontal. Because these are very similar, this right here is also going to be beta. So that's where I get my 20 degrees from. Continuing on, we get sum of forces in the y direction. We're going to have a positive 60-pound force, sine of 20 degrees. It's going to come out to 20.521 pounds. Now that force is done, we'll move right on along to the 80-pound force. Sum of forces in the x, you're going to get positive 80 pounds cosine of 60 degrees, which is going to be 40 pounds flat. I got 60 degrees from looking at where it's coming at from the vertical right here. So I already know that this is 20 degrees and alpha from the given is 40 degrees. So therefore from the horizontal to there, 2 point for the 80 pounds is just going to be 60 degrees. If you have any problems with that, pause the video and work it out yourself, but you'll come out to 60 degrees. This one I use. You can use any other part of degree you want. Just make sure you keep your sines and cosines congruent with all of it. You can do whatever direction you want. I chose to do 60 degrees. Forces in the y direction, we're going to have a positive 80-pound force, sine of 60 degrees, which this will come out to 69.282 pounds. Now that one's done. We will move right along to the 120-pound force. Now this one's different because it is going down 2 point G. So our forces are going to change a little. Forces in the x, we're going to have a positive 120 pounds cosine of 30 degrees, which will come out to 103.923 pounds. I got 30 degrees because of the 20 degree angle from the horizontal. We know our alpha is 40 degrees. We need to find the remaining to get up to the vertical point, and it will be the same for this angle from the horizontal. And that come out for 30 degrees. Again, you can find whichever angle that you wanted to use that's better for you. Just make sure you keep your sines and cosines the same. In the y direction, we're going to have a negative 120-pound force at sine 30 degrees. This will come out to a negative 60-pound force. Now that those three are done, we can find our total resultants in the x, total resultants in the y. All you do is you sum the forces in the x and the sum of the forces in the y. I'm going to go ahead and let y'all do that math. It will come out to 200.305 pounds and 29.803 pounds. Find our total resultant. You just take the sum of the squares, which is the sum of the x and sum of the y, squared, plus 29.803, make that a little better, squared. Our total resultant comes out to 202.510 pounds. Same thing as 2.36, we need to find our alpha. To find that, you just take the inverse tangent of your ry over rx, which will be 29.803 over 200.305. Alpha is going to come out to 8.46 degrees. And those two are your answers for this problem. If at any point, again, you get lost, feel free to pause the video, do some catching up. And if you have any questions, feel free to email me. I know that the exam is coming up really soon. If I can't answer you in time, I do apologize. I'm also working on my midterms as well. So if I cannot get to you, I do apologize. Reach out to Jackson if you can. Otherwise, study these nice and you'll be just fine. And stay tuned for part 3 for the remaining.